Hi, it's Jocelyn, and I'm about to do Advent of Code Day 15. Alright, so again we have some really long numbers. I have no idea how to pronounce the title. We've almost reached Exit of the Cave. We're supposed to not hit some things. The very low ceiling risk level. That sounds familiar. Alright, okay, so this is actually just the graph. So first of all, we're going to parse it. As always, we're going to use a hash map for that. So hash map new. We're going to enumerate these. And then same over here. Yeah, and this is the risk level. So that is 2-digit base 10 dot unwrap. Wonderful. And now we have our maps. So we're trying to find, we now have our maps. So we're trying to get to the bottom right. So what we want to know is the lowest possible, the lowest or the cheapest way to get to each possible location. So we're going to initialize that to just like infinity, and then we're going to do a breadth first search and try to find, or best first search, I guess, and try to find the best path. So what that looks like is we create another hash map, and this is going to be best.insert yx. And this is just going to be u32.max. And then at the very top, we know that that is, let's see. And now we're going to, now we're going to get a list of locations to go to next. So, and so first of all, we're going to visit 0, 0, and the cost to get there, I think, is just 0. The starting point is never entered, so its risk is not counted. Wonderful. And then while let sum, and we have y, x, and cost is equal to visit.pop front. Then we're going to say, if cost is less than the best we have right now for that position, then we are going to set the cost, or set the best, to that new cost. And we're going to push the things, and then we're going to push the new options beside it. So for dy dx in the 4 directions, visit dot push, let's see, visit.push, that's going to be y plus dy, x plus dx, and then we're also going to push the cost plus the map for that position. And then we'll see if those are good. And then once we've done all of our visiting, then we're going to say, then we're going to return rather the best for the max y, max x. And that will be a U32. We of course need to get the max y and the max x. And again, we just care about the last one. So this will run for all the iterations, but the very last iteration, it'll be highest, and that's the only we care about. All right, I definitely want to run the example here. And that's 40. Push back. Oh yeah, this whole thing's a tuple. This is also a tuple. We want to do push back. And this again is a tuple. Ooh, yeah, so this needs to be an I size. Okay. And these are U sizes. Darn it. Okay. I'm just gonna make these I sizes so we don't need to worry about the negative numbers. This will be an I size. Just make them all the same. Maybe it would have been easier just to deal with that in this particular case. But the other thing, actually, yeah, I'm just going to go back to this part and say, if x is, yeah, let's see. So let y is equal to y as I size plus dy, and x is equal to x as I size plus dx, and if y is greater than 0 and x is greater than 0 and y is less than or equal to max y and x is less than or equal to max x, then we can push this just fine. That's kind of gross. Oh, I made a mistake there. That's good that I caught that. These numbers are all pretty small, so we don't need to worry about the difference between signed and unsigned there. Okay, and that's a really high score, which is not great. So let's see. Let's see what we're visiting. I do not see anything there. Am I just like not? So I pushed something to visit, so I should at least get the first one. Oh yeah, we did get the first one. So if I had this in debug mode, it would have caught the overflow, I think, but I guess it didn't in this case. So cost is I32, map, those are U32s, so we can just copy that to, or change that to I32s. This is just like hilarious in terms of my types. I don't know why this time I did so bad. But hopefully the types are good now. And let's compare it to the cost. So 0 should be less than that, right? What are the types here? So cost is I32. Best at that should also be I32. What am I missing here? Okay. So that works. And let's see. So we're checking yx compared to max y, max x. Oh my goodness. This is just hilarious. Okay, the example passes. That's crazy. Okay. And now we can uncomment part A and see if we get an answer. We do. All right. It is 609. As you can see it there. And it's right. Let's go to part 2. Okay. The entire cave is actually 5 times larger in each dimension. Okay. And the area we originally scanned is just 1 tile. Okay. All of its risk levels are 1 higher than the tile immediately up or left of it. However, risk levels above 9 warp to 1. Don't understand what that means. So if you're okay. Oh, I see. Okay. So it's like the same tile except we increase by 1. Well, this is going to look a bit different. The main thing is, I think instead of a VecDeck, we're going to have to use a slightly smarter structure, just based on how long that first one took. But it shouldn't be too bad. Let's see. So the first step is just like filling out the additional tiles. So for Y tile in 0 to 5, or 0 to 4, I guess, and then for X tile in 0 to 5, if Y tile is 0 and the X tile is 0, then that's just the original and we can continue. But for all the other things, we just need to recreate it. So the tile length, or the let's see, tile width is equal to max x plus 1. I just don't feel like adding all those plus 1s later. Feel like I'm gonna mess that up. So and the height is max y plus 1. All right, so now we're going to insert, let's see, for y in 0 to max y, and for x in 0 to max x, we're going to figure out what the tile should, or what that tile should be. So it says that its risk levels are 1 higher than the tile immediately up or left of it. So what do you mean up or left? I guess that means left unless you're the left, and if you're the left, then it's up. Okay, that's kind of annoying. We can just look at the position in the original tile, I guess, for if it's on the left, and otherwise we look to the top. If it's on the very, yeah, no, this is annoying. It seems simple the way they described it. Anyway, it's y plus y tile times tile height, and x plus x tile times tile height. So I'm just going to special case the left side and otherwise do it to the tile to the left. So if x tile is equal to 0, then we'll do something, otherwise, or then we'll look at the tile above it, otherwise we'll look at the tile to the left. So this will be map. Okay, so that is y plus y tile minus 1 times tile height, then x plus x tile times tile height, I think. Then that is going to be plus 1 modulo 10. Something like that. We'll print it out and see if we get it right, just because this seems a bit subtle. And that needs a semicolon, and this needs a semicolon. So if we're not on the left, instead of this, we're going to look at the tile to the left. So that one. And we are not using tile width, which means I messed something up. And indeed there, I'm using tile height for both of them. Okay, so now I'm just going to try printing it. So for y in 0 to, let's see, tile height times 5, and then for x in 0 to tile width times 5, we're going to print the map character. So that's map yx, and then we're going to print a new line. Okay, and then I'm going to just hide this for now. Just going to just straight up panic. Example 2. And the answer eventually will be 315. All right, so over here I have a map, and I'm just looking at the right there, and that seems like the characters on the right are matching. Oh, nope, the character at the bottom is wrong. Oh, no. Oh, wait, no, never mind. Yeah, the character at the bottom, right, on this example it says 6-9, and over here it says 7-9. Oh, I messed up how the wrapping works. First level is above 9, wrap back to 1, not to 0. So I'm just going to make a function which handles that, called wrap. Okay. And that's just going to be a pretty simple function that takes I32, returns an I32. So let I equals I plus 1 modulo 10. If I is equal to 0, we want 1. Otherwise, we want I. Oh, I called that map. I said I was going to call that wrap. Oh, and we said we're doing the plus 1 over there. We don't want plus 2, so actually just I modulo 10. Okay, and now it looks like it matches, just at least from a cursory glance, it looks like it matches the examples. So now we can move on to the next part. Well, actually before that, we also need to remember to fill our best. So this is just best.insert y plus y tile times tile height and x plus x tile times tile width. Okay, now this will be too slow, I think, but we can run it anyway. So I think there's like a min heap, or there's like a heap. There's like a max heap, or what is that? Binary heap. Priority queue implemented with a actually explicit panic, right? I left this over here. So I just have a feeling this will be too slow, but and that we'll need to use the priority queue. And this way, we're ignoring all the solutions or all the like known bad spots and just sticking to ones which are small and probably pretty good. Though we're getting an answer, right? Let's see. Oh. Yeah, no, max y and max x aren't actually that anymore. So that is actually 5 times tile width minus 1, or sorry, tile height minus 1, and that is 5 times tile width minus 1. Okay, at this point, both, oh, actually, I probably should have kept that the same. I should just fix max y and max x here because we also use them over here. So let max y is equal to tile height minus 1 and max x equals tile width minus 1. Times 5 minus 1. Oh my goodness. That's really embarrassing. Yep, and we see here part B is taking too long. So, well, I'm going to just start using a binary heap, start implementing that. So that this can just be sortable, we're going to put the cost first. So I think it says it's a max heap, which means it's going to, every time we push to it, it's going to, or every time we pop from it, it's going to take the highest value. We're actually interested in the lowest value, so I think it gave some tip about that, which was to use reverse. Okay, so reverse just reverses the, it's like we could make the cost negative and this would have the same effect. So we're going to say visit.push, and then we're going to push the reverse of that cost. And I think this should be like a lot faster. This also needs to be reverse. Okay, so that is a lot faster. However, now our example for example 2 passed. So we should be able to just try this answer for part B. And that's the right answer. All right, so the reason this is so much faster is with a breadth first search, we're looking at lots of places that we know aren't going to be very fruitful. But when we're focusing on things that just have a low cost, all the paths that we're not going to be fruitful, we just never see. So that's it for today, and I will see you tomorrow.